Hi, and welcome back, my best chemistry students, to our discussion of models of atomic theory. And so far we've talked about 2 of our 4 quantum numbers. So let's do a quick review and then move into the third. So this shows that picture that we saw last time. And remember, we had N, we had our energy level, and then we had L. Now, L at this level, we're simply going to be using letters. So we've got an S, and we have P, and we have D, and we have F. And we went over this in class too when we looked at those orbitals on that winter site. S is the spherical shape, P are the dumbbells, D's more of a clover leaf with a funky little exception here with a little satellite ring, and then F gets very much more complicated, as do the excited G and H and so forth. Now, N here, if we have S, we can start at 1, and we'll call that a 1S, and then we'll have a 2S, and we'll have a 3S, and so forth. So once you start a sublevel with an energy level, it keeps going. So that's what we can have for N. Now for P, it does not start until 2P. When you're in AP chemistry, we'll talk a little bit more about what's allowed and why. For now, we can just say that it's not physically reasonable for an electron to maximize attractions and minimize repulsions there. But you notice that the P does not start until energy level 2. That number in front is our energy level. Now, for the D's, we don't start until 3. So we would have 3D and 4D and 5D and so forth. And what's wonderful is the periodic table is going to tell us all this at the end. I think you'll really like that. Now, F doesn't start till energy level 4. It's very complicated. You'll see it's going to hold a lot more electrons, and so it needs to be further, electrons need to be further from the nucleus to move in this type of an energy pattern. So remember, as you increase N, you increase energy of the electron, and you increase the distance from the nucleus. So you don't see F until electrons are quite far from the nucleus. Now we want to get to our third one, and we've already talked a little bit about the pattern of these numbers. Our third quantum number is M sub L. Now L tells us shape, N, remember, told us distance and energy. M sub L tells us the orientation in space. So it's going to tell us how many ways it can be oriented in space. Now there's only one way we can orient a sphere in space. And so there's only one M sub L. And we're going to denote that at this level with a line. So how many? So the number of orientations is going to be shown by using a line. Now, some places will use a box, others will use a circle. I just find that it gets a little messy if you do that. So I like to use a line. It's nice and simple. A dumbbell can be oriented 3 different ways, X, Y, and Z effectively. So we'll use 3 lines to indicate our number of M sub L values for our P sublevel. And the D has 5. Man, once you see this on the periodic table, this is going to click so well. So this has 5 orientations associated with it. And then the F has 7. So now we see our pattern 1, 3, 5, 7. And hopefully you could guess that G would have 9 and H would have 11 and so on and so forth. But these are not ground state. Electrons can't have these if they're in a ground state configuration. So now we're really getting close to being able to build up a model of that elusive little electron. So let's recap here. So each sublevel contains, let me get a fun color here, each sublevel contains orbitals. I wish we didn't call them orbitals, but we do. So orbitals are finally regions of high probability for finding an electron. Electrons are just too small for us to identify exactly. And there's a guy named Heisenberg, and you should know this name. I want you to write this down. It's the Heisenberg uncertainty principle. And Heisenberg uncertainty principle says that we can't know the position and the momentum, and momentum is mass times velocity. So in other words, we can't know the position and velocity of electrons with any exact value. We can only get to a probability. Anything we do to find position, any experiment we do to find position messes up the velocity. The more we know velocity, the less we know about position. And there's an old joke that says, you know, Heisenberg was speeding along on the Autobahn and a police stopped him and pulled him alongside the road, and the policeman said to him in a harsh language, "Do you know how fast you were going?" And Heisenberg says, "No, but I know my position." Okay, we'll move on. All right, so orbitals, regions of high probability for finding electrons. It indicates the orientation in space. And the number of orbitals is related to our sublevel L. Each orbital, we saw that, right? A sphere can only have one orientation. The dumbbell shape that we call P for L is got 3. Now, each orbital holds 2 electrons. And we're going to see in a minute how we depict those 2 electrons. That's a bonus quantum number. The surface of the orbital is drawn to represent the area where a particular electron can be found most of the time. So, an orbital is a region in space where there's a 9% probability of finding an electron with a given energy. You want me to say that again faster? An orbital is a region in space where there's a 90% probability of finding an electron with a given energy. So, 90% probability. Now, let's take a look at this again. The S sublevel has 1 orbital. Its spherical shape. We'll give it a line, and we will give it a single line, whether it's a 1s or a 2s or a 3s. It doesn't matter. There's only going to be 1 orbital, right? The numbers in front give you n. So this is n, that's L, and that's our M sub L. The line is what we're using in our model. A P has 3, and it's going to have 3, whether it's a 2p. Remember, you can't have a 1p. They don't exist. It's too close to the nucleus. Or a 3p. It's still going to have 3. And so on and so forth. So you might think of this as a neighborhood, and N is the neighborhood. And in each neighborhood there are houses, and we might have a 1-story house, which is our S, or we could have a 3-story house, and that would be our P, or we could, you know, I'm kind of out of room here, we could have a 5-story house, like or a condo type place, and that's the D, and each story represents our M sub L. And we're going to have 2 people that can live on each story. So that's maybe an analogy that could help. There's another one in the video in just a little bit. So that gets us our quantum numbers. And at this point, we are about ready to go into our model. We're going to fill out a summary table and then move into our model. So until then, this is... Whoops. Signing off.